Okay, we're going to take a look here real quickly at cross products and finding the product of two vectors. Don't worry about some of these other, we're not going to tackle some of these things as part of this chapter or this unit. To find the cross product, this means that not only do we have two products that we're dealing with, or two vectors that we're dealing with, but our outcome is going to be another vector. We use this in electromagnetism. If you have a magnetic field and then you have an electron or say a loop of wire flowing through it, what direction is the force? And that could have a change on the behavior of the electron or a change on the actual wire itself. It could force a wire to go one direction or another. So we use cross products to deal with things like that. The definition of it is here. And I have to tell you that I'm not sure that I would be able to remember this. And I will show you the way that I do it, just so that maybe if it's easy for you, then great. If it is not easier for you, go ahead and memorize this, this algorithm or formula. Okay, so the way that I do it is I line up I, J, and K. And this is the whole reason they call it cross product, because you're doing three crosses. So let's say the first one, let's say this is vector V and this is vector W, right? So I'm going to go a little bit lighter on that one here. So let's say we have oh goodness, that's not any better. There we go. Let's say we have A1, B1, and C1. So that represents our parts of that vector. It's a three-dimensional vector. And W is going to be represented by A2, B2, and C2. Okay, and the reason why I'm doing this is I want all of our outcome to come just like that. Okay, but I'll show you how we're going to do it. First, we're going to go ahead and get our I situated. And our I just gets set like that. Then we're going to subtract our J. And then the third thing we're going to do is add our K. So every single one of these cross products should be put in this format. And if you look up here, you have a negative and a positive in between that I, the J, and the K. So we have our framework. When I have a cross product, right, if I'm looking at my I, what I do is I essentially cross out everything related to I, and I'm left with these items. When I have these items, I'm going to do a cross. Okay, so I is off limits, so I'm not going to look at those. I'm only going to be looking at these values. So I'm going to take a normal X, right? And the way I do that is B1, C1. So B1 times C1, or C2, excuse me. B1 times C2. See, this gets us where we need to be. And then minus B2 times C1. B2, C1. Okay, so here we have emulated what it is that they gave us. Okay. Now I'm going to go ahead and erase those crosses. And now we're going to look at J. When we look at filling in J, again, I'm getting rid of this. So I'm left with these and these. So I'm going to do a cross product here and a cross here. So it's going to be A1C2, A2C1. So A1C2 minus A2C1. Okay, and that's exactly what they have up here. And then the last one, we're looking at K, and again, my K is off limits. So this is what I'm going to be doing my cross product with, A1B2, A2B1. So let's see here, A1B2 minus A2B1. Okay, so that is how, and of course that matches with this. So that's how we do it. Let's go ahead and actually use real numbers because I think that might help a little bit. And I'm going to take these two vectors and I'm going to put it into my format. Again, if you prefer to go ahead and memorize the equation, please feel free to do so. I'm just going to show you the way where you don't have to memorize the formula, you just memorize the process. All right, so I'm going to write I, J, and K. And first I have vector V. That vector V is going to have 2 as my I, 3 as my J, and 5 as my K. Vector W has a 1 as my I, right? Because there's nothing there, it's just 1. It has a 2 as my J and a 3 as my K. All right, let's go ahead and build our equation. So I have 2 parentheses plus I minus 2 parentheses J plus 2 parentheses K. All right, so I'm going to do 3 times 3, which is 9, minus 2 times 5, which is 10. Does that make sense? Okay, now I'm going to erase that so that it's not in our way. All right, now I'm going to do J. And J, remember, we're going to go to our A and C. So 2 times 3 is 6, minus 1 times 5, minus 5. All right, and then I'm going to erase those. And then on K, I'm going to do 2 times 2, which is 4, minus 3 times 1, which is 3. Okay, so for this one, 9 minus 10 gives me negative 1i. 6 minus 5 is 1, so minus 1j, right? So this is a positive 1, but I have a negative sign here, so it's going to be minus 1j. And then 4 minus 3 is 1, but there's a plus sign there, so 1k. So I could actually also write this as negative I minus j plus k. So that would be my final cross product of these two vectors. Okay? All right, let's do some more practice. Actually, I'm going to show you a couple rules real quick, and then we'll dive into some more practice of our cross products. Okay, algebraic properties of them. If I have two cross products that, if I cross two vectors that are the same, I'm going to end up with 0, okay? So let's try that real quick. So let's say I have I, J, and K, and I have 2, 3, 4, and 2, 3, 4, right? So I would put together my J and my K. So let's work this out here. So 3 times 4 is 12 minus 3 times 4, which is 12. And then I have 2 times 4, which is 8, minus 2 times 4, which is 8. And then I have the green. 2 times 3 is 6, minus 2 times 3 is 6. So I end up with 0i minus 0j plus 0k. So all those added up together are going to equal 0. So that is what we mean by when you add up or cross product a vector times itself, you get 0. If you take u cross v and you change the order to v cross u, you're going to get the negative value of it. Because what happens is you're switching the subtraction on the inside. And so if you had like 20 minus 10, and that would normally have given you a 10, now you're doing 10 minus 20, and that gives you a negative 10. So all of those signs are going to be 1 off if you do the commutative property, so be careful. When you have a scalar number that you're going to put with a cross product, you need to attach it to one of them. It doesn't matter if you attach it to the u or you attach it to the v, but you will not distribute it through. Do not distribute it through. Pick one and attach it to that vector and then put that through. And then when we look at something that we're going to cross with the addition of vectors, we can distribute that cross product. So that'll be u times v, so that's distributed, u cross v, excuse me, plus u cross w. Okay, so these are things that you definitely want to stick on your emotional support card or your page in your pre-calculus book, okay? All right, let's look at some additional examples. And I'm going to go through 2, and then I'm going to ask you to pause the video so that you can go ahead and make sure that you know how to do the other 3, and we will check our answers. Okay, so A cross B, I'm going to do I, J, and K, and A is going to be my first one that I list. So 6, -4, so see how I have a minus sign there? I'm going to keep that sign with that coefficient. And then B is going to be -9, -5, and -6. Ooh, -9, -5, -6. All right. So my first cross is, well, let's go ahead and write out my thing here. Parentheses I minus parentheses J plus parentheses K. All right, my first one is this cross, right? Because this one's going to be out. So 4 times 6 is 24, and I have 2 negatives. So I have 24 minus -5 times 8 is going to be -40. And then my J, right? I'm going to cross, because these are out, I'm going to cross this and this. So 6 times -6 is going to give me -36, minus -9 times 8 is going to give me -72. And then my last one, right, my K is off limits, so I'm going to cross these. So I have -30 minus, I don't need parentheses there, -30 minus 9 times 4 is 36. Both of my negatives cancel out, so I should have that. Okay, so now it's a matter of actually kind of reducing all of this. I've already used that as much as I need to, and now I'm going to reduce this. So 24 minus a -40 is the same as adding 40, so that's going to be 64i. And then -36 minus a -72 is going to be the same as adding 72. So -36 plus 72 gives me +36. And then I have this negative sign here. So -36j. And then the next one, -30 minus 36 is going to be -66k. Remember, we have a plus sign here, and the subtraction of both of these is going to be a negative. So 64i minus 36j minus 66k, and that's my answer. Okay? Again, if you prefer the other type instead of using this little matrix, that's fine. Okay? Let me just be frank with you. I learned this in physics. I didn't learn it in math. And so this is how we use it in physics. So if you go into a technical subject and you're in electromagnetism in your second semester physics in college that's calculus based, you will end up using this way. All right, so let's take a look. I, J, K, and we have 4, 6, and 5. And then we have -7, 3, and 5. -7, 3, and 5. Okay, I is off limits, so it's going to be 6 and 5 and 3 and 5. Let me write my bracket here. I got so ready to do the math that I forgot my bracket. All right, so 6 times 5 is 30, minus 3 times 5 is 15. And then my next grouping, my J is off limits, so it's going to be 4 times 5 and -7 times 5. So 4 times 5 is 20 minus negative 7 times 5 is negative 35. And then my k, that means this is off limits, so it's going to be these two crossed. And so 4 times 3 is 12 minus a negative 42. Okay, so 30 minus 15 is going to give me 15i. 20 minus 35 is the same as adding 35, so 20 plus 35 is going to be, remember I have a minus here, 55j. And then 12 minus 42, that one is the same as adding a 42, so that's going to be 54, and that's a plus right here, so plus 54k. So that's my answer, 15i minus 55j plus 54k. So I want you to go ahead and see if you can go through 3, 4, and 5 on your own, and I'm going to go ahead and show you how those are done. So pause the video and do that now. Okay, let's check your answers. So in this one, we have I, J, K, negative 8, negative 7, negative 8, negative 4, negative 9, and negative 4. So we have a lot of negatives here. And we have our framework here. All right, so 7 times 4 is 28, both negative, so it stays positive. 9 times 8 is 72, both negatives, it stays positive, so 72. Negative 8 times negative 4, that's this one times this one, that's going to be 32. And then negative 4 times 8, this one times that one, is going to be minus 32. And then we have 8 times 9, right? This last one is this. So negative 8 times negative 9 is 72 minus negative 4 times negative 7, which is 28. So we should have negative 44i minus 0j plus 44k. And that I would probably reduce to negative 44i plus 44k. I wouldn't leave the j in there if it's negative, or if it's 0. All right, let's take a look at number 4. Number 4, I, J, K. 1, negative 5, negative 1, negative 6, 1, and 0. That's interesting. Okay, so I minus j plus k. All right, so my first grouping are these two. So I have negative 5 times 0 is going to be 0. 1 times negative 1 is going to be minus 1. And then and then we have these. So I have 1 times 0 is 0 minus negative 6 times negative 1 is positive 6. And then the last two is going to be this times this. So that would be 1 minus a positive 30. So 0 minus 1 is negative I. 0 minus 6 is negative 6j, but I'm subtracting a negative, so it's going to be plus 6j. And then 1 minus 30 is negative 29, so minus 29k. All right. And then real quickly, we will find the last one. So I, J, K, 3, 0, 4, 6, negative 9, and 7. All right, get my framework. Minus j plus k. And so I have 0 times 7 minus negative 9 times 4. So it's going to be 0 minus negative 36. And then my next grouping is going to be 3 times 7 minus 6 times 4. So it's going to be 21 minus 24. And then my last one is going to be 3 times negative 9. Oops, I did not mean to use an actual thing there. 3 times negative 9 and 6 times 0. So 3 times negative 9 is going to give us negative 27. 6 times 0 is going to be 0. So I have minus a negative is the same as a plus, 36i. 21 minus 24 is negative 3. Minus a negative 3 is the same as plus 3j. And then negative 27 minus 0 is negative 27. Okay. All right. So we've gone through all of them on the cross products, and hopefully that will help you be successful on your homework.